So this question came in MMD exam. This is related to your DC shunt generator, two generators running in parallel. The question, 220 volt DC generator, each having linear external characteristic, operated in parallel. One machine has a terminal voltage of 270 volt at no load and 220 volt at a load current of 35 amps, while the other has a voltage of 280 volt at no load and 220 volt at 50 amps. So calculate the output current of each machine and the bus bar voltage when total load is 60 amps, and what is the kilowatt output of each machine under this load. So first target is to find the output current of each generator and the bus bar voltage when total load is 60 amps. So before going into solving the question, we will understand what is this linear external characteristic. See what happens. Initially, when the generator is connected on bus bar and it is supplying no current to the bus bar because there is no load on the bus bar, like no motor has been switched on. So in that case, its voltage will be is maximum. For number 1, you can see 270 volt at no load, means load current is 0, voltage is 270. And 220 volt at a load current of 35 amperes. So when you have increased the load and given a load of 35 amps, its voltage has dropped down to 220 volt. Same for the second generator, 280 volt at no load and 220 volt at 50 amps. So how is this voltage changing with the load current? That characteristic is linear. So we will understand this first. See, generator is generating the voltage. So we will draw a graph between voltage and the load current. This is the voltage and this axis is representing load current. When load current is 0, means no load, the voltage is V0. Let us say it is V0. We mark it here. As the load started increasing, the voltage start dropping, but that dropping is linear. Like this. So this is what is saying in the question. How to write the equation for this linear characteristic? You write voltage at any load current IL, initial voltage means no load voltage, minus some constant K1 or K. You should write K, we should not specify K1 now, into IL. You can see when no load, when the current is 0, load current is 0, this portion is 0, so V is equal to V0. So it is following this. So this is the way to write the equation. So this is the linear characteristic equation. Now collect the data what is given in the question. For the first generator, let us give it a name. Okay, first generator. No load voltage is 270. Voltage for the first generator at no load means zero current, zero load current, 270 volt. Voltage of the first generator at no load means zero current is equal to 270 volt given in the question. Voltage of the first generator when the load current was given 35 amps. So we should write this 220 volt and load current of first generator 35 amps. Collect the data for the second generator. Similarly, voltage of second generator at no load means zero current, 280 volt. 220 volt at 50 ampere. Voltage of number 2 generator at 50 ampere, 220 volt. Current is 50 amp. So it is asking when these two generators are running in parallel like this, generator number 1, generator number 2, and suppose this is connected, and this is connected, this is load. So it is asking output current of each machine. What output current this will give, number 1 machine will give, and what output current number 2 machine will give. The total current is, load current is 60 amperes, means through this 60 amperes current is flowing. That is total load current if we write as total IT. So to find is, first is output current. Output current, if we say for the I1 for the first generator as I1, and for the second generator I2. So this is what voltage at the bus bar. This is your bus bar. So what is the voltage at the bus bar? You can write V bus. So our first target is this. Now you see you have these two information. So we will write the linear characteristic equation for each generator. So for the first generator, you write the equation voltage of number 1 generator, no load voltage minus, let us say K1 is the constant, and IL for first generator, I1L. So now use this, what is at 135 means for the first generator at 35 ampere. So what was the voltage? So replace this with this. Load current was I135 for the first generator, 35 ampere. Put the value. Sorry, V135 is 220 volt. V10 is 270. I135 is 35 amps. So your K1 is 10 by 7. Now for the second generator, you write for the second generator. Similarly, K2, I2L, second generator load current. If you replace this V2 by V2 at 50 amperes, V20 is 280 volt. I2L will change to I250. I250. So V250 is your 220 volt. This is 280. K2 I250 is 50 amps. Six by 5. So you get the value of K1 and K2. So means you got the equation of voltage of each generator in terms of load current. Now the total load total load now is 60 amps on both jet generator. Means together it is 60 amps. So at that time, if IL1 was flowing through number 1 generator and IL2 was flowing through the number 2 generator, then IL1 plus IL2 is equal to your 60 amps, because IL1 will go like this, IL2 will come like this, and together it will come here. So this is your, let us say, equation A. At that time, let us say the bus bar voltage was V bus. We have written here V bus, V subscript bus. So with the help of this, we should K2 and K1, we should write the equation, the linear equation for first generator and the second generator first. So our first generator voltage V10 is your no load is 270, right? If I am correct, it is 270. 270 minus K1. K1 is your 10 by 7, sorry. This is 10 by 7 into I load current in 1. Which we have written as 1. Similarly, for the second generator, V2 will be 280, because no load voltage is 280 if I am not wrong. 280 minus K2 is 6 by 5, and your load current number 2. For both the generator to be connected on bus bar, the voltage should be equal. So this V1 should be equal to V2, that is V bus. So put the value of V1 from equation 1 and V2 from equation 2. So you will be getting 270 minus 10 by 7 into IL1, 280 minus 6 by 5 into IL2. Okay. Put the value of IL1 from equation A. So this will become IL1 will be 60 minus IL2. Use the calculator and get the value of IL2. Where is IL2? I 36.4 ampere. This calculation part you do by yourself. So from equation A you will get IL1 IL1 plus 36.4 is equal to 60 amps. So IL1 will be 60 minus 36.4, that is 36 323.6 amps. So these two are the output currents. One, this is for number 2 generator and this one is for number 1 generator. This you write IL1 and IL2 since we have these two you got already. V bus is same as V1 is equal to V2. So you can use any equation, like okay, use equation 1 from equation 1. At IL1 current, IL1 is 23.6 amperes. So your V1 is equal to V bus. We have written this. So V bus, you can directly write this and put the value 270 minus 10 by 7 into IL1 is 23.6 amperes, 23.6, and calculate for it. So what is coming? The bus is 236.3 volt. 236.3 volt. This is 270. So 270. So this also you got. So this is another answer. The bus bar voltage. This one is the answer for bus bar voltage. Now it is asking the kilowatt output. The kilowatt output of each machine under this load. So we know the power. Okay, kilowatt output of number 1 generator. Let us write like this. Bus bar voltage into current given by number 1 generator. Your bus bar voltage is 236.3. IL1 is your 23.6. This will be in watt. So you divide it by 1000 to get in kilowatt. How much? 5.57 kilowatt. Similarly, you can write for kilowatt output of number 2. You write in word, I am writing in shortcut. Okay, for exam you should write in details. V bus into IL2 to 36.3 into IL2 is 36.4, and this one is 8.6 kilowatt. This is in watt divided by 1000. To get in kilowatt. That is 8.6 kilowatt. Okay. Compile all the answers in one place and write so that examiner will find it easy to see. So your answer should be like this. Your answer should be, you compile finally. Okay, IL1, the load current of number 1 generator, this much. IL2, this much. The one which you have brought, which you have calculated already. V bus bar, this much. Kilowatt output of number 1 generator. So your answer in the exam should be like this, in one place, after calculating all the things. So hopefully you understood the concept. This diagram I have made it for your convenience to understand. When it is connected with the bus bar, this is also connected with the bus bar. Bus bar voltage will be same as that this one is generating and this one is generating. Load has been connected, so 60 ampere current is flowing through the load. Part of the current is coming from number 1 generator, part of the current is coming from number 2 generator. At this point, these two currents are meeting and then going to the load. That is 60 amps. In case any doubt, yeah, you can write in the comment box. I'll clarify that. Thank you.